morning, children. Continuing with the chapter Forces and Laws of Motion. Today we are going to do Newton's third law of motion. The Newton's third law of motion states that when an object exerts a force on another object, the second object immediately exerts a force on the first. These two forces are always equal in magnitude but opposite in direction. These forces act on different objects and never on the same object. In other words, you can say that there is a pair of forces, not just a single force. The two opposing forces are all called action and reaction forces. Yes, for example, children, the interaction between a hammer and a nail. Hammer exerts a force on a nail and drives it into a board, which is called an action force. And nail exerts a force on the hammer, which is a reaction force. Whenever one object exerts a force on the second object immediately exerts equal and opposite force on the first one. You can see, children, now the example also of a balloon in the figure. That balloon, from the balloon, the air is coming out. The air which is coming out, it is an action force, and in reaction, children, the balloon moves up in the air. That is a reaction force. Yes, children, now you can see in this figure that this girl is swimming. She is swimming. A person moves forward during swimming. When a person swims, he pushes the water in a backward direction with his hand. This is an action force. And in reaction, the water pushes the person in the forward direction with equal force. Yes, children, in another figure, you can see the boat is moving backwards into the water when a person jumps out on the bank of a river. This is due as the person applies a force in the forward direction. The reaction of this force acts on the boat in the opposite direction, and due to which the person moves in the forward direction and the boat moves backward in the direction. Yes, children, you can see in another figure, this is a rocket. The hot gas is coming out of the nozzle of the rocket. That is an action force, as they are coming with a force. And due to this action force, the rocket moves up. That is a reaction force. Yes, children, now one more example. That boy is walking on the ground is also an example of Newton's third law of motion. As the boy, he applies the force of his feet on the earth. That is an action force. It moves the earth backwards very slightly. But the ground, the force of the ground from the earth on his feet, that is a reaction force due to which he moves forward. These are the two laws, this is the law of Newton's third law of motion. Now, children, let us move to the law of conservation of momentum. Yes, children, you can see in this figure that suppose two balls are moving, and A and B, suppose two balls are moving having a mass m1 and m2, and they are traveling in the same direction along a straight line, but they are traveling with different velocities. One has a velocity u1, another has a velocity u2. And after a certain time, that when there is no external force acting on it, and the ball A, it is moving with the more velocity than the other, and after some time, two of these balls collide, and during collision, which lasts for few seconds, the ball exerts force on each other. The first ball A exerts force on another ball, and the second ball B exerts force on the another ball, and due to which their velocities changes. From u1, its velocity changes to v1, and on the other ball, the velocity changes from u2 to v2 in this time. According to this law of conservation, children, which states that the total momentum before the collision and after the collision remains same unless and until the external force is applied on it. Or you can say the sum of the momentum of the two balls remains the same after and before the collision. Yes, you can see the derivation, children, here, that as two balls having a different mass, A and B are the two balls having the masses masses MA and MB. They are moving with the velocity UA and UB. After some times, when no unbalanced force is exerted by them, on them, they collide with each other. The ball A exerts a force on B and B ball exerts a force on A. But according to third law of motion, they both exert force on each other, but in the opposite direction. After applying a force on each other, then what happens? Their velocity changes from UA to VA, children, and from UB to VB. This is after the collision. Now, if we say that the force exerted by the ball A on B is equals to MA into VA minus UA upon T. From where it has come? You know that, children, the second law of motion states that it shows that it is the force, unbalanced force is the product of mass and acceleration. It is mass is ma and acceleration is change of velocity, rate of change of velocity. Earlier the velocity was ua, now the velocity is va, final velocity, so in time t. So what is the rate of change of velocity? It is va minus ua upon t. Same is with the ball B, children, that you can see that it is also exerting force on ball A. So it is showing that mb is equals to rate of change of velocity, mass into acceleration. That is vb minus ub upon t. vb is the final velocity after collision and ub is the initial velocity before the collision, and vb minus ub upon t is the rate of change of velocity, that is acceleration. As we know that according to third law, both the balls are exerting force on each other but in opposite direction. So children, we have written FAB, that force exerted by A on B is equals to force exerted by B on A, that is by ball B on A, but as they are exerting the force on opposite direction, so we have put the sign of minus here. Okay, children. Now, we can write the values of FAB, that is already written, that MA VA minus UA upon T, which is equals to MB VB minus UB upon T, but with the minus sign. Now TT cancels, and when we see, we find that it becomes MA UA plus MB UB is equals to MA VA plus MB UB. MAUA plus MBUV was the initial momentum of this before the collision, and MAVA plus MBVB is the final momentum after the collision, children. Now, what does it show? This is the law of conservation of momentum, which states that the sum of momentum of two objects before the collision is equals to after the collision, provided no unbalanced force is exerted on it. And this is called law of conservation of momentum.